Welcome to DR.HSB classes. Today we will be starting a very interesting topic in mathematics, that is introduction to limits. So limits is part of the class 11 syllabus and moreover in the JEE main syllabus, JEE and boards. So we will be looking at both of these aspects at the same time. So we will be starting the board section of the introduction to limit part. We will start by the definition, the concepts and the examples. So this part will be divided into several videos. So you can watch all those videos in the playlist later when we will update all the videos at the same time. And so let's start. What is limits, right? So the first thing that comes in your mind is what is limits. So limits is a very integral part of calculus, because in calculus our main focus is to know what is the nature of the function, what the function behaves. So if we have a function, suppose y equals to fx, so how this function behaves is the way we are dealing in calculus. So behavior of functions. So behavior of functions, this is the main motive behind study of calculus. In this part, we will be obviously looking into the several behaviors of function, and one such behavior of function is limits. So a function can increase, a function can decrease, a function can increase at some rate, a function can lead to several properties or several family of functions. So these are the main concepts that we obviously try to understand and analyze in calculus. Now, so we will look very intuitively what is meant by limit, and we will give you the epsilon delta definition also. It is not required in the board syllabus, but in the upcoming lectures we will obviously know how to derive the limits or find the limits of a function using this epsilon delta definition. But we will first today analyze how to define limits using an intuitive manner. So an intuitive manner means, suppose, let me draw this function. There is a function, suppose there is a function y equals to fx. We are not defining what is the actual formula for expression for this function. We are not telling that it is x square or x cube. We are not dealing with that. We are taking just y equals to fx. Let me be clear about it. Now, this is the x-axis, this is the y-axis, this is the origin. So this is y equals to fx, and moreover, suppose we have a particular point x equals to a, where x belongs to domain of f, because we can't take values of the x outside the domain of f, because suppose the domain of the function is defined from real to real. So there is no problem in assuming that we can't take any point outside a particular intervals per se this. So it is not a problem in that case. So what we will do now is, if I take a value x equals to a in the domain of this function, so this is the x-axis, so this is the independent variable, and this one is the y-axis is the dependent variable. So if we put a value x over here, we get some, if we put a value of, suppose say x1, what we will assume, y1 will be f of x1, y2 will be some f of x2, where x2 is over here. Okay, so it is very easy to understand. If we change the values over the domain, we will have different values of the function defined from real to real, because we are taking this type of functions only, right? Now suppose if I have a and some a1 and a2, and I am trying to decrease the value such that these are our ordered values, that is a is less than a1 less than a2, because this is an increasing part of the real line. Now we are trying to decrease the value of a of this a sequence, because it is, suppose this is a0, it is better to say a0. So at this point we are trying to decrease the points in a, decrease the values in a towards a0, and we will know what is the value of this function. So suppose a2, the functional value is f of a2. At a1 the functional value is f of a1. At a0 the functional value is f of a0, right? This is clear. F of a2 for this part, f of a1 for this part, and f of a0 for this part, right? This part. So from here it may look a bit clumsy, but I will give you further examples. This is the intuitive definition, right? This is not the perfect definition of what is a delimit. So I will tell you f of a1, f of a0, and here a0, a1 and a2 are there, okay? So f of a1, f of a2, f of a1, f of a0. Now if I try to decrease all these values, so we will get different values for let's make a table. So these are the a values and this is the f of a values. So a for a0, this is f of a0. For a1, this is f of a1. For a2, this is f of a2. So for these values we can obviously know what is the nature of this function. Why? If I try to add more values to this region, suppose I add a f of a3 over here, there is no problem in assuming a3 over here, because it is a sequence, it can change from random points. So a3, so f of a3 is over here. If I add infinitely more values over here, so we will get the list of the table will go up to, yes, obviously infinity. So it is at a, suppose we are reaching a very high stage, so we can't list all the values because this is infinite. This is infinite, so we can tabulate all the values. But what has happened, as the a2, a1, a3, a4, a7 dot 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 dot, these are all, 4 is not, 7 is not coming after 4, but between there are a5, a6, okay? So up to a0. So what we are doing, we are shrinking, we are trying to shrink. This is the point to note. We are trying to shrink the values of the domain towards a particular point. Okay. Towards a particular point we are trying to shrink this value. After trying to shrinking this value, we are trying to analyze where will the function fx, the value of this range or codomain, what you say, will go. Suppose it goes to some L. So in an intuitive manner we can obviously say that if x goes to some a in the domain where a belongs to the domain of f domain, then where does fx tend to? This is the question that limit answers. This is the question that, this is your requirement. If x goes to some a which is in the domain of this function f, if x goes to some a which belongs to the domain of this function, this belongs to the domain of f, then where does f of x tend to? If it tends to some L, then we will obviously tell that L is the limit of fx when x goes to a. So this is the normal way of analyzing what is a limit. Okay, so we will give you a particular example over here. We will give an example over here. By giving a particular example, suppose fx is x square, and suppose I am taking the x, we will form a table. So suppose x is 0. So where is fx going? It is going on 0 square. So this is 0. If this is going to 0.1, then where it is going? 0.1 whole square, that is 0.01. Suppose it is going to 0.02. Then where it is going? It is going on 0.004. So this is the places okay, yeah, this is the place where the functions are going. Suppose if I assume this, then where it is where fx is going? On this. So you can tell there is not a much increase in the values. It is obviously decreasing by very amount. So obviously there is a downward slope, because if we are moving away from 0 to some point between 1, we are actually decreasing the value of this function. So we are trying to analyze where this function will go. If we go in this direction, that is from 0 to 1 or from 1 to 0. So there is two ways of analyzing this way. Now the general case that we follow is 1 to 0, because it is easy if we follow the real line. If we go from 1 to 0, then it is best analyzing, because you can say over the values this is decreasing over here, so it is better to show in the other direction. Now if I take from this to this, so there are two ways. Now listen carefully, there are actually two ways to analyze the function. Let me draw over here. So you can reach, now I am making the real point out of all these parts I have told. This is the real point. The first real point is, the main point to be noted is, if x goes to some b, where does fx tend to? B or a, you can take anything. Okay, b or a, anything. If it goes to L, then L is the limit of L is the limit of fx. Now if I want to reach 0, this is my target point. I want to analyze the value of x tends to 0. This means two things: right hand way of reaching and left hand way of reaching. Okay, this is the right hand way of reaching and this is the left hand way of reaching 0. So I can obviously reach 1 to 0. Okay, 1 to 0 from the right hand side of 0. From the right hand side of 0 I can reach from 1 to 0. From the left hand side of the 0 I can obviously reach 1 to 0, minus 1 to 0. So there are two ways of reaching 0. As we are trying to analyze where x is going, that is 0. That is, we want to analyze if x goes to 0, then where does fx goes? This is the function, or this is the main motive that we are trying to discuss. Now suppose, so if x goes to 0, right hand way, okay, right hand way, so this is the limit of the function is known as right hand limit. Okay. Now if x goes to 0 left hand way, then it is known as, obviously you can understand, it is left hand way. left hand limit of reaching 0. So there are two limits actually. There are two limits to analyze whether a function or whether a point in the whether a point in the domain can be reached. So the x values, okay, the x values, these are the x values, these are the x values of the domain. If this tries to reach 0 or some a or some 2 or some 4 or some 7.8, no problem. If this tries to tend to 0, this can be done in two ways: left hand limit, right hand limit, or left hand way of reaching, right hand way of reaching. So there are two limits associated with one point. There are two limits associated with one point. Now, suppose if fx is x square, the earlier example I was talking about, if I want to analyze at x equals to 0, okay, if we want to analyze at x equals to 0, what we want to analyze, where does fx go, that L we are trying to find out. This is the main motive. Now x can be reached in right hand way, so we will write this notation in a new way: x tends to 0 plus. Why? This is 0 and 0 plus is known by a point which is greater than 0 on the right hand side. Obviously greater than 0 is on the right hand side. Now, and left hand limit we will find by where x goes to 0 minus. So these are some values, right? These are some values we will calculate, but the main domain will be looking into this. So these are the two partitions of the domain, or two partitions of the point at which we are trying to analyze the limit. Now suppose we will find the left hand limit. How to do? So that is the main question over here. How to do the left hand limit? If our left hand limit is limit x tends to 0 minus f of x, this is the notation of writing the left hand limit. Okay, this is the main notation we will be using to analyze left hand limit. Limit fx x tends to 0 minus. So we will put fx equals to x square this is what we have got. Now what is there? Now we can't put something over here, right? Because this is some value which is less than 0, right? But we don't know which value. So there is a problem, because these are mathematical variables. The x square and x cube, these are all mathematical variables. So this does not mean that we can put any number which is less than 0, and we don't know that number to find this value. We don't know which number x naught we are putting over here, and we can't find the value because this is a mathematical variable. So what to do? We will do a substitution. We will write x equals to 0 minus h. Why? Because as h now, as analyze, it is better to write over here. Suppose x is 0 minus h. As h tends to 0, then where does x tend to? It tends to 0 minus, because as h is decreasing, where it is going? 0 minus some k value which is less than some k1, which is less than some k2, which is less than some k3. This sequence is going. So we will obviously get a value which is less than 0. So which means that this condition is satisfied if we do this substitution. Obviously we will write limit h tends to 0, 0 minus h whole square. Now as h is tending to a particular definite number, there is no minus plus over here in h, so it is going to 0. So we will put the value in this function to find the limit. So this is 0 minus 0 whole square, this is obviously 0. So the left hand limit what we have calculated has come around 0, or you can understand from here also. Now this is our first work. Now what we will do right hand limit. Right hand limit is something that same thing, x tends to 0 plus of fx. So what is this? X tends to 0 plus x square limit. We will do some substitution, 0 plus h, because it is some value which is after 0. So 0 plus h and h tends to 0. So what we will do? We will write h tends to 0, h tends to 0 and x square. Now so obviously this x is obviously 0 plus h whole square, because we have made the substitution. Okay. So it is h tends to 0, h square, which is 0 again, because if you put 0 square is 0. So LHL equals to RHL equals to 0. So both are 0. Then this is a very supreme condition actually. If this is true for any function, if the LHL of that function equals to RHL of that function equals to some constant, if this is true, or we can say also this, if the LHL and RHL are equal, then the limit will obviously exist. So this is the criteria for existence of limit. Okay, this is the criteria. I am writing over here also. If LHL equals to RHL, then limit of a function will exist. This is the main criteria that we will look into in next videos, and we will analyze another example, the last example for this video. This is a board based lecture. Okay, this is suitable for CBSE state boards and all those other boards, but for the JEE part we will upload some videos which will be uploaded soon, but subscribe to the channel if you like. Okay, now we will look at the second example, that is fx equals to x to the power 4 plus 2. It is an awkward looking function. So why we will analyze where x tends to 2, where does fx go? So LHL we will find, because we know to find the limit means to find LHL and RHL. If they are equal, then obviously we will say either of the value is the limit. If limit exists, LHL is the limit or RHL is the limit, so we don't care. If we know LHL and equals to it is RHL, so any one of the values, as they are both equal, any one of them is L, right? So LHL is limit x tends to 2 LHL is limit x tends to 2 minus f of x, that is limit h tends to 0 where x equals to 2 minus h to the power 4 plus 2, because in x place of x we are putting this. Now put h equals to 0, 2 to the power 4 plus 2, what it is 18, right? Now the RHL is same, limit x tends to 2 plus fx, limit h tends to 0, 2 plus h whole to the power 4 plus 2, this is 18 again, because if we put h equals to 0, it is coming 18 again. So LHL equals to RHL is 18, and this is the limit of fx. It's simple, this is limit, right? Limit of fx, limit of this function. This is what we are trying to analyze. This is the limit. So this This is the first lecture on how to analyze what is limit. We will obviously give you the epsilon delta definition, which is actually good for required for JEE mains, actually JEE advanced also, and KVPY, all these exams. But this is the basic limit definition, and some two examples we have discussed on how to find the limit and how we are analyzing the limit by shrinking a value towards the function on the left side and shrinking a value towards the function on the left hand side, right hand side and left hand side. We are analyzing two ways actually of getting to a domain point. So I hope you can like and subscribe to the channel. Thanks for watching.